I'm Lauren Millar. This time on Journeys, I'm going to introduce you to the Lady of Montserrat. For nearly 400 years, she lay sleeping on this tiny Caribbean island about 50 kilometers southwest of Antigua. One day she awoke, and she awoke with such a fury she shot rock and ash thousands of meters into the sky. The capital city of Plymouth had to be evacuated, and scientists from around the world have descended on this tiny island to monitor the crisis. Now, she looks rather benign right now, but we are going to follow the scientific team through the worst volcanic activity in Montserrat's history.
Observatory, Mike Sierra.
We can report that there is a massive new growth on the dome, which has grown up into a large scar which went all the way up into the central upper portions of the dome.
The worst eruption in Montserrat's history started like this, with steaming hot rock forcing its way up through the volcano core to perch on the peak. The rate this volcano dome is growing is unprecedented, and at any moment the entire mass could collapse and plummet into the valley, pulverizing every living thing in its path.
That is an impressive sight. For those of us who spend our lives looking at volcanoes in books and labs, you know, to see it actually going on, that growth rate, Mark, must be way up there with the world record, you know.
Some of that stuff might be behaving like a very viscous liquid.
The scientists have never seen anything like it. Mark Stasiuk is head volcanologist here from England's Lancaster University, with John Shepherd, head geophysicist. They coordinate the team of scientists that have converged on Montserrat to observe the volcano and advise government.
When it does that,
And despite their expertise, the volcano's behavior is a
the
puzzle.
system below drops off.
No one has ever seen such an unusual chain of events. No one knows what to expect.
The worst case scenarios are that we could have pyroclastic flows that are very active, which come down on the opposite side of the dome and go directly towards Plymouth.
Tucked in the volcano's shadow lies the capital city, Plymouth, once a busy port and commercial center, now deserted. An eruption on Mother's Day, the third in less than a year, caused a massive evacuation. Schools, churches, businesses, all abandoned, as 6,000 Montserratians fled for their lives. And now, months later, the volcano shows no sign of backing off.
Observatory, Juliet, Sierra.
Observatory, yes, sir.
Yeah, well, there's another column and another one coming up. It's really starting to speed up a bit at the moment. Juliet, Sierra, standing by. This is the fastest rate of growth I've seen. You know, it's a bit unusual, in fact. Domes usually start fast and slow down.
Yeah.
This one has gone on slowly for quite a while, and in the last, look at that, sorry. Observatory, Juliet, Sierra.
Sierra Observatory.
Yeah, there's a fairly significant ash column now starting from the summit of the dome pops. It might start to dump ash over on your side very shortly. Over.
Field teams are in constant contact with the Volcano Observatory to report their findings. They rely on the observatory's seismic instruments to forewarn them of danger signs. With volcanic activity increasing, this is the most dangerous place on the island.
Don't go in there!
Don't go in there now! Do you want to say something to them, John?
I've said something to them. I mean, I'm not a policeman. I mean, I'm just advising them. See, look at that one coming down just behind Castle Peak.
Yeah,
There's
that's
a
the
huge boulder.
same path.
Yeah. Observatory, Juliet, Sierra, another significant increase in ash production resulting from what looked basically like two large boulders coming down just to the right of Castle Peak. Over.
This is a pyroclastic flow. As scalding rock collapses from the volcano peak and tumbles down the mountain, ash-laden clouds billow. What happens below the surface that we're not seeing?
Somewhere below the surface there's some big source of magma. Usually they're sort of between 5 and 15 kilometers deep, and we call them a magma chamber. It's a sort of mysterious thing we don't know much about, but it's like a big tank, and it's under pressure, maybe because of gas buildup down there, or because of pressures being put on it by the motion of the tectonic plates in the area. And that material is being pushed up towards the surface, and this is how it reaches the surface. So, it looked like from the helicopters, though, more than just this nearest part of the dome was growing. It looked like there might be other parts of the dome were also growing. Right. And if they fell, some of the material would go over or towards other parts of the crater rim, and that's what we're most afraid of.
It's an inherent problem with this volcano. It doesn't just go boom. You know, if the activity keeps on at a fairly constant level, it's very alive, very active, and it's a huge problem for everybody concerned, because there's so much uncertainty whether this thing will shut down in a week, a month, a year, or 10 years. Yeah, look at all this ash. Man. Okay, point 2.
Thanks, over.
That's fine, it's a little ash, but it's alright.
John Stix is a volcanologist from the University of Montreal in Canada. He's measuring the amount of sulfur dioxide gas vented from the volcano using a correlation spectrometer.
Yeah, go.
Billy Daru is on the Montserrat police force. When the volcano first blew, he ran, camera in hand, toward the pyroclastic flows. Now he's learning to be part of the scientific team.
Okay, normal.
Normal.
Okay, hopefully we can get one more run.
Yeah, we can.
We are interested in measuring sulfur dioxide fluxes in tons per day, metric tons per day, to see if there are changes during the eruptive activity of a volcano. So, for example, before a big eruption, the SO2 content may increase. Before an eruption, the SO2 content may decrease, depending on the type of the volcano and the volcano's behavior. But essentially what we're looking for are changes with time.
SO2 gas absorbs ultraviolet light. By measuring the ultraviolet light, John and Billy can determine the amount of SO2 in the air. Light enters the lens, passes through a series of mirrors, and is then converted to an electrical signal.
Jesus! Man, that's a big column.
John and Billy drive several times under the plume of gas, and each time they take a reading to calculate an average measure. While keeping their eyes on their data, their ears are tuned to the radio, aware at all times they're in the danger zone.
Excellent, that's great. It's really important data today. It looks like we saw a burst last time. We were lucky to see a higher.
We've got a full signal coming in on all stations.
Okay. So it's very interesting, because now there's going to be ash. There, you can see the ash started now. So we just finished the run, or we're in the middle of the run, and we beat the ash, which is good, I think.
I would say about 200 meters above the escarpment, so we'll get you loud and clear. Standing by.
Observatory, Kilo 1.
Kilo 1, Observatory, go ahead.
I am with Charlie Oscar. We're on St. George's Hill, and we're looking at a very impressive ash column now, over.
That ash column could mean the entire dome is collapsing. However, John and Billy need one more measurement to complete their work, which will lead them right toward that plume.
Look at this line down there, straight lines down the ash.
What does that mean?
Fallout.
Yep,
It's falling.
Fall out.
The ash is
And maybe
falling.
falling pretty fast.
Okay.
These are the columns that pass over Plymouth, and it's totally black.
Right.
Yeah.
Right.
We've got another signal coming in, all field parties, perhaps similar or larger size than the last one.
Okay, so let's watch this and see what happens. Here it comes. There it is, right there. Very nice. Very nice.
Despite the danger, John and Billy venture ahead with their work and are now surrounded by a very large ash cloud.
7, 6, 5, 4, 3, 2, 1, and stop.
A wind speed measurement is calculated with SO2 readings for an accurate assessment of sulfur dioxide in the air.
1606.
1606.
That's it. Good. Ready?
Yeah.
Start.
Okay.
Without wind speed, their morning's data won't be accurate. So John and Billy take the risk.
The leading edge is still moving slowly. It's stopping about 200 meters, 150 meters short of the rim.
Yeah.
Radio reports from scientists around the island now warn of dense, continuous ash plumes from huge pyroclastic flows. as the volcano's dome collapses. And the wind has dropped. That means it's certain the ash cloud will fall from the sky. When and where is anybody's guess.
There seems to be an enhancement and escalation of activity. It may be only temporary. We haven't seen anything like this before here since the crisis began. Whenever you see something at an active volcano that doesn't follow the normal pattern, that's exciting.
Billy, would you write down wind data on a piece of paper so I can read it?
Soon it's clear Plymouth will not be the target of the next ashfall. We will. Okay, we're having a serious ashfall, and it's covering the Viewpoint Hotel. Within minutes, we're consumed by swirling black ash. The air is so thick with sharp, stinging particles we can barely see or breathe. And the smell of a burnt match hangs in the air. It's inconceivable that a brilliant sunny day can be rendered dark as night by falling ash. We ran for shelter inside the Viewpoint Hotel where a magical calm prevails. Out of nowhere, it seems, emergency candles appear. And the Rotary Club continues with lunch as Montserratians determinedly resume life as usual.
He don't have that.
We feel at least somewhat protected in the shelter of a hotel. The field teams are still outside. At this point, it's impossible to predict what will happen next. With dust masks firmly in place, businessmen from Barbados muse that they've picked the wrong day for a meeting in Montserrat. So I guess this is what they mean by white, wet, ash falling. I don't know whether we showed you pictures of this before, but this used to be a turquoise swimming pool. It's now raining very hard, and it's just thick black ash falling out of the sky. It's hard to believe that much mud has fallen, but this is just thick now with volcanic mud. Look. So this used to be a pool patio, and now in a matter of 15 minutes, all this has happened. Mud has fallen, ash has fallen, and devastated this place. And they keep saying that this isn't the worst, and that has fallen on Plymouth and elsewhere, and it's not going to be the last.
Some people were saying, wow, this is the big ones. I mean, what would the big one be like? Well, I can't tell you whether it's a big one or not, but I think we'll keep on having these flows. They may be bigger and bigger because larger volumes are involved, as the dome is bigger and then it's more unstable. And this is probably the largest pyroclastic flow episode that we've had so far. Again, we have a lot of ash on the ground, and I think we had a little rain as well, so take great care in driving, and we do not see any need at the moment for people to panic.
How would you describe the rate of growth?
All that we can do at this moment is make very much hand-waving estimates. Our best estimates are that the rate of growth of the dome, up to yesterday anyway, clearly we can't say anything about today, was one of the fastest that's ever been observed. We're talking about something between 5 and 10 cubic meters of new material per second. That's about the size of this thing. This Jeep I'm sitting in is about 5 cubic meters.
Per second.
One or two of these Jeeps every second.
My best guess is that pressure is built up for some reason at depth in the magma reservoir. at a few kilometers depth. But I really have no idea why. We have very little data on that.
Why is it hard to make predictions?
Well, there's lots of reasons. One of the biggest reasons that we can't make predictions is that, as you've seen, it's an extremely dangerous place. And to get close to it, even to within a kilometer would be considered very close. And it's just too dangerous to make the sort of predictions that you need to make detailed measurements. So we lack the data we need to develop an understanding.
Soon all the scientists are accounted for and gather at the Viewpoint Hotel, completely exhausted yet charged. The ashfall was caused by a complete collapse of the volcano dome. Scientists say the pyroclastic flows blasted 7 kilometers down the mountainside all the way to the sea. That hasn't happened with such force in recorded history. Well, it certainly makes it seem real.
Yeah, it really puts you into a state of shock. Such a sudden, dramatic, and a change of such immense magnitude that you can't observe it. Every time I go back to the Tar River, I don't really recognize it.
I think this is telling a very, very, very interesting story. The increased seismicity, the increased gas levels, the extrusion rates, clearly magma is moving up and degassing at a much more significant rate. And all these parameters we have not seen before. So this is all new.
Because they're so unpredictable, we're constantly concerned about what might happen.
Like the ash flow wasn't too pleasant.
But that was a very small event in terms of what we've seen in the geological record. There's lots of volcanoes in the world that have produced eruptions, which have been many orders of magnitude more destructive than what we've seen here.
But as the scientists reflect, another plume swells to monstrous proportions.
We're constantly thinking about the danger. I mean, there's been quite a few volcanologists killed in recent years, and everyone wants to get as close as possible to see what's happening.
We'll have to proceed pretty carefully because we don't actually know. We don't know what's happening. This is much larger.
The pyroclastic flows may be deviating from their usual path. The scientists are anxious to get close, but how close is safe is the question.
There's something very active is happening. The valley walls that would normally protect us may be getting overtopped.
Those batteries back there?
You're not worried or anything, are you?
I'm worried, sure.
Yeah?
I mean, this is not, what we've been seeing for the past couple months, so it's something different. It seems to be a larger scale of things, but whenever something happens to change, what we've been seeing, sure, it's cause for concern, definitely. And that's a lot of ash.
Juliet, Sierra Mike Sierra, 10 traffic.
Yeah, Mark, I think perhaps you and I should go to Farrell's, leaving the students behind, and take a decision from there on.
Roger, copy that. I'll queue up for the next few minutes.
Could you get me another battery?
Caution quickly gives way to overwhelming curiosity as the scientists pile into jeeps for a closer look. If there's anything worse than an ash cloud about to drop from the sky again, it's one that's about to drop in the inky black of night while you're in the middle of nowhere.
Sorry about the bumpy ride. This Jeep has seen better days.
So is the road.
Well, this is the good part of the road.
Our driver is Glenn Mattioli, an American volcanologist from the University of Puerto Rico. He's studied this volcano for the past year and respects its potential. Last night at dinner, he warned it was developing like Mount St. Helens. An explosion from that volcano in 1980 blasted through the side of a mountain, killing 57 people. If the Montserrat Hills volcano follows suit, there'll be little left on this island.
Okay, this is a place I don't like to be, so we gotta move quickly through here.
Why's that?
Because it's a low point and it's just below the Farrell's notch. Just the point where a pyroclastic flow can overtop the ridge down here and tumble down straight down here. I think this is a far worse place to be, quite honestly.
Moments later, right near that low point, we're stopped. Mattioli's received a radio call telling him to proceed no further. Not because of the volcano, but because the student in our Jeep is not allowed in the danger zone. Mattioli isn't about to turn back, and while they talk it over, we could be in the path of new pyroclastic flows.
Yeah, Pops, I don't particularly like standing right here. I think I would prefer to go up Molyneux or Windy. Over.
Okay, we copy. So as soon as you reach Windy, no problem. We'll give us an update as to where you are. We'll tell you what's going on from our end here. Observatory standing by.
Papa Romeo, clear.
I'm with Papa Romeo. We just...
That radio call could have been a ticket to safety, but thanks to Mattioli's plea, we now plunge deeper into the danger zone. And cliche or not, anything can happen.
That's a roger.
Holy
Just 4 kilometers from the volcano, darkness allows us to witness a spectacle usually hidden in daylight. Massive boulders glow red from their immense heat and break off the dome.
Yeah, rock falls clearly audible from Harris Lookout. Over.
Copy that.
Observatory, Papa Romeo.
Copy.
Yeah, from Harris we saw several large glowing blocks just cave off and roll down the hill. It's hard to estimate their size from here, but I would venture to guess they're on the order of 10 meters in diameter at least. Over. Ooh, that's good. Oh, the whole thing is glowing. You hear that rumble?
Yeah, I do.
Yeah, John, we caught quite a long rumbling period. Clearly there was a significant mass of material moving down slope. Yeah, if you guys can't see anything or can't hear anything from your location, maybe we should pull back up to Harris Lookout, because we have a pretty good view and we can hear from here. Over?
Concerned his colleagues are in the path of new rock falls, Mattioli urges them away. Those boulders travel so fast they'd be upon them in seconds.
Papa Romeo standing by. Over.
At the Volcano Observatory, the squeal of seismograph alarms creates a high-pitched tension. The drums are saturated, as the scientists say, meaning earth tremors are forcing the seismograph needles to their maximum capacity. The observatory measures and records ground movement around the volcano, and along with the tremendous pyroclastic flows we've seen, a strange new earth tremor has developed. One that turns on, then off, on, then off. As magma moves underground, it crushes rock, creating high-frequency tectonic earthquakes. All signs now indicate this volcano has yet to show us its worst.
When you're dealing with this crisis mode, you're running on a lot of adrenaline all the time. You're trying to produce results that evening to see if there are changes going on a day-to-day basis. So it's very exhausting. It's emotionally draining. You're trying to interact with other people. Everybody's not getting enough to eat, not getting enough sleep, and so forth. So it's very difficult.
That's glowing, no question about it. Oh, it's glowing pretty well.
Yeah. Look at that.
Oh, you can see the whole spine. That's the whole spine. So it was glowing on the front side and glowing on the back side, and there appears to be a fissure going up on the original slope.
Yeah, that's what it looked
pre-existing slope of the dome.
That's what it looked like last night as
We
well.
saw it glowing a long way.
So have you seen anything like this since you started studying here?
Well, not with this intensity, no.
Yeah, it was
This is
all right, but
the most continuous flux of ash I've seen. And I think if we go back in the record, it's probably likely to be the biggest single event that we've seen over the entire year.
With the dome again unstable and earthquakes increasing, an even bigger event is certain.
Watch it, watch it! And I think the gas point is going to be right around the corner here.
Yeah, where the smoke is coming up.
After last night's spectacular display, a momentary lull allows the scientists into the bowels of the volcano. As it catches its breath, the scientists need samples. some clue of what's to come.
Springs.
Oh,
These are all springs.
Okay.
Springs.
Yeah, so then the gas point must be either one of those.
That's right.
Yeah.
According to John's map, the gas vent he wants is on a very unstable slope. In fact, we're surrounded by unstable ground. Acid gases from the underground magma interact with groundwater here to erode the rock base, meaning the ground could give way at any moment.
What I need to do is get up there, but it's really hard. Shit.
While focusing on their task, the volcanologists also have a sixth sense tuned to any rumbling sounds or shakes in the ground, any sign the volcano is stirring. It's really quite hard to believe that it is dangerous around here. You have to be careful where you walk. Stay away from big rock formations like this one. I think I'm far enough away, because there's earth tremors constantly around here. And if you are too close to a rock like that, when an earth tremor hits, then it will crush you. Also, they look so benign, but this kind of vent is a gas vent from the volcano, very hot. And so if you just sort of inadvertently step over it while you're climbing through the rocks, you can burn yourself. You can see all the yellow sulfur that's collecting around the area. And it's sort of like a vent from a dryer. It really feels like, you can really feel hot air pushing through there. And stinks like a rotten egg.
Field geology is often a tedious business, just sitting and watching things, detailed mapping, collecting samples, looking at the thicknesses of the deposits, all the sort of things which will help us to tell whether the eruption is developing and define the hazard areas in case it does really decide to turn on a show for us.
Watch it, watch it, watch it!
Look out! Do you ever think, oh boy, I'm in the wrong place today?
Well, if we've planned our activities properly, we're never in the wrong place. We take the proper precautions, we have backup, people know where we are. You know, you just hope things work out all right. It doesn't always, you know, I mean, people in our position have had nasty things happen to them, you know, like getting killed. But normally when you're working, the thought of personal hazard doesn't cross your mind at all. You're focusing on a particular phenomenon, and in a sense you get tunnel vision. You don't. But we always operate in pairs. It's very easy to be looking at one precise thing and not notice that there's a monstrous pyroclastic flow towering over your head. So the other guy is watching out for that.
Why do you have to collect a gas sample?
We look for, you know, the hottest gas vent, where the gas flow is the strongest and the hottest.
Right.
And this has been sampled already, so we're going to sample it again.
You want to see what kind of gases.
Well, yeah, we want to see if what kind of gases are coming out here and see if there are changes with time.
The volcano's mood doesn't last long. Just as the team climbs out, a radio report warns of rocks falling off the dome. Earth tremors are increasing. And somewhere in the distance is the sound of thunder. So this is the first time in a long time that they've been able to clearly see the dome. The clouds are always covering it. And they seem to have just lifted briefly enough to see it, but they're going to see if they can go up in the chopper to see what's been happening with the dome. One of the things that they're very interested in is this what's happening with the spine, which seems to be continuously growing even after it breaks off, causing incredible pyroclastic flows. It seems to be growing at a great rate.
Observatory, Juliet, Sierra.
Sierra Observatory.
Well, it's you should come and see this dome, George. There's a whole new dome there. And it's one of the clearest that I've seen. It's very there's been so much new growth that it's very difficult to describe it. We're hoping to get up in the helicopter. If Jim is listening, we'd like to go up as quickly as possible. Over.
I don't understand how it's changed.
Oh, okay. It's hard to describe, but you see all the material that looks very fresh and is steaming.
Yeah.
Right. Well, and then you see just to the left the spiky bits that are dark. Those are Castle Peaks, and that's a much older dome.
Okay.
The new dome is the fresh stuff, which is growing and sort of growing against and flowing up on top of that. There's just to the right of those spiky ones. It's a very spiky, fresh-looking area.
Right.
It's sort of dark highlights, and that used to be. Yesterday, that was a huge hole, or maybe 36 hours ago, that was a big hole that was fell.
Oh my God!
And that's all grown back.
Report on the seismicity at this moment. We are receiving a harmonic tremor on all stations at this moment. Not so large on gauges, but a little bit large on the long ground. So that's the latest at this moment. We'll keep you informed as it unfolds. Observatory standing by. Echo Delta copy.
Juliet Sierra copies, nothing particular visible here. Steaming and some very small rock falls over.
To give you an idea of the sort of flow rates, we're talking about how rapidly magma is reaching the surface. It's probably something like 10 cubic meters each second. So sort of car size or something, car size every second of magma.
So why are we standing here?
Because we want to watch and see what happens next.
This is the fastest continuous dome growth ever recorded.
John, what do you think it means anything? I mean, I know all these things are very hard to assess and predict, but you've been here for quite some time, and now the activity's increasing quite significantly.
Well, it's a surprise to me. You know, I mean, I thought by this time it would have stopped. I didn't expect it to start up again quite on this scale at this stage.
Yeah, George, go. Yes, vigorous steam production behind the Galway's wall. Yes, George, as you're going to that area, because right now we have an increase in that on our stations here, so you will be on the watch out while you go, over. Okay, observatory standing by.
Echo Delta, Juliet Sierra. Yeah, keep your eye on it there, George. There's ash coming up. You should be able to see it any instant now. Just look carefully when it starts to, the clouds start to get a bit solid. Take care of yourself. Juliet Sierra standing by.
I was just wondering if we can get Jane and Maria.
Oops, see that one?
Yeah, it's coming off the highest part of the dome there, John. You see it's up from between those slabby spines. Oh, look at that.
I was wondering if we can get Jane and Maria.
Observatory, Juliet Sierra. Yeah, that's the first genuine pyroclastic flow that we've seen. Over.
Okay, John, that was the actually our needles are deciding to be clipping on all, or slightly clipping on all four at this moment, over.
Okay, Pops, well I would shut the windows if I were you, over.
John, did you?
Okay, we're doing that. Standing by.
Can't you hear it? Or is it just me? I think from here, Mark, we can probably, we can be out of here in 2 minutes, you know. We don't want to start a panic.
No.
Don't worry about us. We can get out of here quickly, too. So why does a continuous rumble sort of worry you slightly?
Near the upper parts of the new area, there was an almost continuous plume rising, and no rockfalls were visible coming down, which and there was a sort of rumbling, which is what you expect when it's actually starting to go into a bit of an explosive phase.
What does that mean? Lava and steam, or?
No, that would mean a much larger scale of eruption.
You're being so subtle. What does much larger scale?
So
something explosive.
If if it started to go into an explosive phase, then it can be. I mean, the size of that can vary a lot, but usually that means a sustained column much higher than what we've seen before, sort of 10 kilometers high.
It's something I've never come across before.
You've never heard it before?
Never heard it before, no. I've heard roars from volcanoes which are really exploding. This one is not really exploding.
Yeah.
There are two large fumarolic vents on the top of the volcano. It may simply be some sort of trumpeting sound coming from them, but don't know.
Again, we straddle that ambiguous line between scientific curiosity and personal safety. If this volcano is about to explode, there's no telling how deadly that may be. Yet watching history in the making is irresistible.
Observatory standing by.
Juliet Sierra standing by. I don't intend to commit suicide. If it's dangerous, you'll see me go.
How do you know?
Well, you look at the patterns of previous volcanoes like this. When you look at the previous pattern of this volcano, there have been some big flows, but they've not come straight out of the blue. They've all given us minutes of warning.
Right.
But people can get complacent. You know, people have been killed in more or less the situation we are in now. You know, when
The last volcano just killed in a situation much like this,
yeah, almost in exactly this kind of situation.
They were in a place they thought was safe.
They were in a place they thought was safe.
The lava dome growing, it collapsed.
Well, what kind of time frame are you talking about? I mean, if something if it did collapse.
Well, 2 kilometers, 3 kilometers to the dome, maybe 120 kilometers an hour.
Yeah.
Minute and a half.
A minute and a half to escape a pyroclastic flow rushing down the mountain at 120 kilometers an hour. With Montserrat's winding mountainous roads, the odds aren't completely in our favor.
Slight increase in our corner found here, but there was no large amplitude signal. So maybe
it's groaning.
The observatory reports no rock faults that could be associated with the rumbling sound. Something deep within the volcano is stirring.
He's not picking up any rockfall signals.
Well, there's a big groaning noise.
Big rumbles. Like
Big rumbles, like thunder, yeah.
Observatory to all field teams. We're getting a signal that is basically saturated on all four. Observatory standing by. Observatory to all field teams. We're getting a signal that is basically saturated on all four. Observatory standing by. Kilo 1 observatory.
Moments later, the regenerated dome collapses. The observatory warns all field teams of tremendous seismic activity as tons of rock crash down the mountainside. Plumes of ash blow more than 6 kilometers high. Field teams radio back their position and move to safer ground.
Observatory to field teams. Signal is still continuing, still saturated, possible flow, heavy flow again. Observatory standing by.
John Shepard and Mark Stasiuk take to the air to witness the event. Just a few hundred yards from where we were standing, pyroclastic flows decimate the mountainside. Hundreds of degrees in temperature, this flow will incinerate and crush anything in its path.
That information, the intensity has gone back up a bit. Observatory standing by. Kilo 1 observatory.
As scalding rock pounds into the sea, the water literally boils. Moments ago, these floating logs were trees.
Papa Romeo, observatory. Observatory, Papa Romeo, we can get over the water.
As 5 million cubic meters of rock rushes to the sea, the island's coastline changes. A new beach is formed, half a kilometer wide by half a kilometer deep. Hours later, the devastation is revealed. Mark Stasiuk and geologist Alan Smith want samples of the erupted rock, more clues of what the volcano has in store. Charred trees and hot ash mix in a thick, moist smell of cinders and sulfur. And you can feel intense heat as the helicopter flies over gorges carved by pyroclastic flows.
Yeah, this is fine now. This is already going to be fine now.
Finding a safe landing spot will be difficult. The new beach is hot and unstable, And to be in the path of another pyroclastic flow is unspeakably dangerous. But rock samples from this beach could be key to understanding whether things are going to get better or worse.
Right by the water's edge, I think it'd be ideal.
They decide to land on a slip of beach cooled by the sea. Their excitement is tempered by grave awareness of the risk. But it seems when volcanoes are your passion, danger becomes a relative term. The beach is hot and spongy and full of sinkholes. Mark and Alan will have to take great care and collect their samples fast. While they work, Jim keeps the chopper just touching the ground. The lift from the blades prevents us from sinking into hot sand that hours ago was at least 400 degrees centigrade.
It takes a while to sink in how hot 400 degrees is, and that's nowhere near the temperature of magma. 4 times the boiling point of water, and it just is something we can't conceive of. That's part of the interest as well, because things like that we can't conceive of make it fascinating.
This beach is so hot that waves evaporate before they make it back to the sea. Success! Mark and Alan have collected brand new rock, fresh from the depths of the earth. Inside these rocks are the secrets of the volcano's next move.
Hey, Mark.
We were probably the first people to be actually seeing pyroclastic flows running into the sea like that.
Is that right?
Yeah.
How does the activity here rate in terms of the things that you've seen?
I've been through a number of eruptions, and it's one of the biggest eruptions that I've seen personally. But this one is still developing, and we don't really know where it's going to go, so it could be a real big one.
You see the water coming out down there in the chopper?
It's still clean, believe it or not.
Still clean?
Halfway down the mountain, another field team stops to talk to a farmer who waters his cattle here every day.
We can't get there no more now.
John Stix, Clive Oppenheimer, and Jim McMahon view the damage to this farmer's land.
Because it's been running there for years, from since I know myself. And I dwell out here for years, because I was just born there, so.
He tells us his name is Prince. His family has farmed this land for generations. He's lived here all his life.
But you see, I born out here, I real out here, I know the whole guts and gall of out here.
I think being involved in a crisis situation such as this means that you're making an active contribution to a very practical problem, trying to help understand the behavior of a volcano and its effects upon people, livestock, agriculture, and so forth, i.e. on the environment around the volcano in a populated area. As we do basic research on volcanoes. With our knowledge, we can apply what we've learned to a crisis situation.
However, despite the scientists' prior warnings, Prince could not leave the Tar River Valley. He has nowhere else to go. And today he lost everything. His entire herd of cattle destroyed in the volcano's path.
So, young rock. This week's rock.
Mark and Alan return with their samples of freshly erupted rock. They suspect the rocks will reveal whether the volcano is building toward an explosion. If that happens, a disaster many times the magnitude of what we saw today is in store.
We are beginning to see some signs that the magma that's reaching the surface is getting a little bit gas-rich. We collected some rocks yesterday which have got bubbles in them. Not an enormous number so far, but they look fairly different from what's been erupted so far.
So what does that mean, if it has bubbles in it as opposed to having degassed?
Well, volcanic explosions are caused by rapid expansion of gas. It does slightly increase the possibility that we might get a few explosions here.
So, young rock. This week's rock.
That's what it came in.
Really?
Yeah, gets carried around down in that stuff.
Wow, this is amazing. It's still this warm.
Well, it's been washed by the seawater now.
Right.
Cool. Still too hot to get any. The tide has been up over this stuff. It's too hot to get any further in.
Is that right?
Yeah, oh yeah. I mean,
You said
pouring
it was
water.
70 degrees.
Yeah, it'd be much hotter.
Yeah, well, that's 70 degrees after it's been in the bucket and been carried
Yeah.
out.
Yeah. And also sitting down
Yeah.
at the base.
Where Jim was about to land with these steam plumes.
Yeah, that's right. There was all this steam coming, shooting out of little holes. No, veto.
Not here. What motivates you to do this kind of work? It can be a bit dangerous. There always some sort of danger just kind of over your shoulder. Why do you want to do this kind of thing?
Well, it's all sorts of motivations. The first one is really the pure interest. They're just fascinating.
Why?
I mean, well, you saw it this morning. I mean, they're just amazing things to behold. They're awesome. In 10 cubic meters a second of material coming up, building a whole mountain peak and virtually overnight, and then the whole thing falling down into a valley, destroying kilometers wide swath of valley. That's just absolutely fascinating. But also, the opportunity to be involved in a monitoring program like this is, in a sense, is a wonderful culmination of our interests, because it allows us to actually have an impact sociologically on a positive result to actually help people, which is a very good feeling, I think.
Observatory, Mike Sierra. We can report that there's a massive new growth on the dome, which has grown up into a large scar.
What began as unprecedented dome growth, then extraordinary pyroclastic flows, continues in Montserrat. The volcano shows no sign of backing off, but neither is it accelerating, so no explosion is likely, for now.
One and stop.
The journey for these scientists has been intense. Despite the undeniable danger, the challenge of scientific exploration is irresistible. Each test, every new bit of data is a missing piece of the puzzle, bringing them closer to revealing the mysteries that lie at the volcano's depths.
Observatory, Juliet, Sierra.
Yet despite all the tests, knowing exactly when and how the volcano will erupt is impossible. And in the mystery and the danger lies the fascination. Each successive pyroclastic flow has been more destructive than the one before. Unpredictable and uncanny. This volcano has made history. No telling what she has in store.
Observatory standing by.